So this video is about public and private key authentication, which is basically a way of getting secure SSH to various servers without actually having to enter passwords if you configure it a certain way. And that's kind of what we're interested in here, the ability to really conveniently go hop from server to server to server without ever punching in any passwords. So the concept at a very high level is that we want passwordless SSH from system A to system B. And the way we accomplish this is we're going to generate a private key and a public key. The private key you really want to keep private. This is your identity. For all intents and purposes, if someone has the private key, they are you. Think of the private key as your own identity. And the nice thing about public key, private key authentication is if it just so happens that your private key gets compromised, you can revoke access to all of your servers for that private key and create a new private key and start over. So it's sort of like changing the locks on your house. And the public key is something that you place on the servers that you want to log into with passwordless SSH. So if you want to go passwordless SSH from system A to system B, then private key goes on system A, which is the system you want to do passwordless SSH from. You want to start from system A, that's where your private key is, because it needs to know this is who you are. It needs to be able to say, yes, I am this person, you're coming from this machine, and I am this person. And then the public key goes onto system B that you want to log in to, and it's able to use the public key to authenticate you. So put the private key on the system you want to come from, and put the public key on the system you want to go to, and we'll give a couple of examples. We'll run through this on Windows with Putty, on Ubuntu for Windows, like Windows subsystem for Linux, and also on Ubuntu server. Going from one Linux server to another Linux server. So you can do this for sort of local to remote hops and also from remote to remote hops without too much work. So let's say we want to connect to a remote system B at this IP address, and we're going to use Putty. We want to go just from our local system running Putty. So I can punch in that host name, and we want to be able to connect to that without any password. So what we have to do is we have to generate a public and private key pair. I'm assuming that you've never generated a public-private key pair, because if you've already done this and you know how to do this, you're not watching this video. So assuming you've never generated a public-private key pair before, you're going to run PuttyGen, PuttyGen, and you just need to download and install Putty and PuttyGen and Pageant. They're all part of the same package. And then you're going to select a key type. Let's just go with the default for now, although ED25519 is probably the best out there right now. Let's just try generating a 2048-bit RSA key. So we'll click generate, and then it wants some randomness. So you mouse over the blank area to generate some randomness, and now you get a public key, and you also have a private key, and you have to go save private key file. So I'm going to save the private key file. Do I want to save it without a passphrase? Of course, you can put a passphrase on your private key so someone has to punch in a password to use it. But that would kind of defeat our purpose here because we want no passphrase on this, and I can save this. So we'll call this temp, identity temp private key. I'm just going to give it some, whatever, arbitrary temporary name like that. Okay, now that you've generated your private key, let's keep this open for the moment, because you don't really want to lose your public key. Let's just save the public key as well. So let's call, I called that identity temp private key, it's called identity temp public key, and let's make it a txt file, because it's basically plain text. And now that we've generated that stuff, we can close this. Now we're going to open Pageant, which is the way that Putty actually gets access to keys. So what you do is you register your keys with Pageant. It's already running in my case, but that's how you would run it. And it shows up in my task tray. So I'm going to double click it in the task tray and pop this up. And here I have some public keys, or some private keys already registered with their public key components showing. So I'm going to go add key, and I'm going to locate on my computer, not my usual identities location, but here's the private key that I just generated. I'm going to add that. That gets added to the list. I just generated it here. And close. And now Pageant has made Putty aware of that key. So now I should be able to log in to this machine which is expecting that key, if this machine is expecting that key. But the thing is, this machine has to be expecting that key. How do we make this machine expect that key? Well, we have to log into it and paste our public key on that machine. So I'm going to log into it here using sort of the default classical approach of using a password. So I'm going to SSH to that machine. I have to specify the username. So here I'm SSHing to that machine. The first time you connect to a machine, it's going to ask you if you trust that the machine you think you're connecting to really is that machine. I do. And it actually gave me a passwordless login because this Ubuntu for Windows that I'm currently using already has passwordless SSH set up. So let me just disable passwordless SSH by removing the authorized keys file, and I'll try that again. So I logged out. I'm no longer on that machine, which by the way is called Scuttle. So you can see when I'm local and when I'm remote. So I'll try to SSH into that again. Now it's asking me for a password, so I'll enter that password. Okay, so I had to use password authentication. So what we have to do is we have to go into the .ssh directory on the remote server. We're on Scuttle, the remote server now. And it already has some IDs here and some stuff that we wouldn't normally expect to see if this was a fresh installation. If this is a fresh installation, you've never done this before, we have to create a file called authorized keys. I'm going to use my favorite text editor, Micro. And what we do is we're going to paste the public key that we just came up with there. So let me pull up the public key. So here's the public key. And this format that Putty generates, where the public key is split up onto lots of different lines, that's not the format that Linux expects. So what we're going to do is we're going to just combine all of the lines. I'm just going to remove all the line breaks here, and then it expects a comment at the end. So this is kind of how Linux expects to see it, and we'll paste that key here, just like this. So it's like the actual key as just like a single long chunk of text and then the comment at the end. So that's how Linux expects it, and I'm going to save this file. So now that our public key is on that server, close that, I can go back to my Putty window, and I can try to connect. So it's going to ask me who I'm logging in as. I can log in as Trabot, and it's asking me for a password. So it seems like we haven't actually successfully made this connection. So let's just make sure that the authorized keys looks okay. Okay. I'm going to pause the video for a second just to make sure I haven't messed anything up, and we'll be right back to this. Okay, so I made a pretty silly mistake here. If you look at this authorized keys file, there's actually something missing from the beginning, and that's some sort of token to specify what the actual protocol is. So here, this is an RSA key, and there's nothing there to specify that because I took Putty's weird format that it exported and just sort of like, harlequined this thing together. Better approach is to reopen PuttyGen and then open up the private key that we generated, and then just go back here to see public key for pasting into OpenSSH authorized keys file. And here you see the SSH RSA tag. This is exactly what you want to paste. And if I paste it right below, you'll see this is almost exactly the same, but it's slightly longer. It has the SSH RSA thing at the beginning. So I kind of screwed that up, but that's okay. We made that change, and I'm going to try again with Putty to log in to that server. So hopefully this time it won't ask us for a password. So I'm going to plug in this, and I can also plug in the username automatically, so I'll type Trabot there. And we'll try to open that. And there we go, we connected without a password. So now we're actually able to access that without a password. If I save that in Putty, then I could open that and never have to enter a password. So this isn't quite what I did here. I actually logged on to remote using a password and edited the .ssh home/.ssh/authorized keys file. So I edited that directly. Okay, so that's what we just did. And that's sort of how we got Putty to be able to connect. Now, what if we are not using Putty? What if we're using, for example, Ubuntu for Windows? So you can install Ubuntu on Windows, at least on Windows 10, and it runs essentially something called Windows Subsystem for Linux, which is like a Microsoft implementation of the Linux kernel, and Ubuntu is sort of installed and ported on top of that. And so this is pretty common if you're doing Windows development. You're probably using Ubuntu for Windows. So you might want to be able to connect from Ubuntu for Windows to the remote server. I'm currently on the remote server. Let me get off that. So here I'm on my local machine and I want to ssh.remote server, and it's asking me for a password. I don't want to have to enter that password. So now we're on this section of the document, Ubuntu for Windows. So we want to go from our local system, our Windows 10 desktop, to the remote system, this. And it's asking for a password. And the way I do this on Windows Subsystem for Linux is I'm going to generate a key, so ssh-keygen. So I canceled the login to that remote server. On my Windows Subsystem for Linux, Ubuntu for Windows in distribution, I'm going to run ssh-keygen. This is the equivalent to doing PuttyGen. It's asking me, where do you want to save it? I say I want to save it there. I already have an RSA key here, but I'm just going to overwrite it. That's fine. What password do you want? Nothing. Okay, there you go. I generated an SSH key. So this is the public key has been saved in id_rsa/pub. The private key has been saved in id_rsa, like ssh.ssh/id_rsa. Here we have .ssh/id_rsa_pub, where we've saved the public key. So let's go .ssh/id_rsa.pub. There you go. There's the public key. And what I want to do is take this public key, as before, and paste it on the remote server. So I'm going to SSH into the remote server. I have to enter a password this time, and I'm going to edit the .ssh/authorized keys file. Now we have our other key in there. Let's paste this new key in there. So now we have this new key pasted in there. We're going to save, log out. Now we're back onto my local machine. When we SSH in this time, no password needed. So we used Keygen. We used ssh-keygen to generate the key pair. Using for Windows, we used PuttyGen, and for Ubuntu for Windows, we used ssh-keygen. So this is a local Ubuntu for Windows install that we can easily SSH without a password to this server, where we put the appropriate public key in the authorized keys file. Okay. So that's Ubuntu for Windows. What about if we're trying to SSH from one remote server to another remote server? So here I have just a simple tutorial VirtualBox VM that's basically a remote server that we want to, from the perspective of this computer, it's a remote server, and we want to be able to SSH in a passwordless way from this to that other remote server, 129.whatever. So if we SSH there right now, this is very similar to the Ubuntu for Windows instructions. Here we need a password, of course. So what we're going to do is we're going to do ssh-keygen. Oops. Why can't I type? Okay. It would appear that I've messed this window up. Let's just connect to that again. Okay. Sometimes with all these layers of terminals, strange things happen. Let's run a new tmux session, and let's SSH into 129.97.60.144. Okay, we'll connect, and it asks for a password, and we'll log in. Okay, so we're able to log in with a password. Let's exit. Now we're back on this remote Tribot VirtualBox machine. So we exited from the remote Scuttle machine to the remote Tribot VirtualBox machine. Now we're going to do ssh-keygen. And yes, we'll save it there. No passphrase. There we go. Let's cat the ssh/id_rsa_pub. This is the public key that we're going to place on the remote server. The private key is just in our SSH folder. It's this id_rsa. Let's copy the public key and go put that on the second remote server. So we're going to SSH from this first remote server to the second remote server. Enter the password, and then we're going to edit the authorized keys file in this remote server. We're going to add yet another key here. It would appear that my copy paste did not work well. I must have done something silly, so I'm going to copy this here. I'm going to paste it into a separate window here just so I make sure I don't lose it, and then I'm going to paste it directly in here. Okay, so there it is. I've pasted this third key in there. So now I can access this remote scuttle server from this VirtualBox remote server. So I've SSH from my local machine to this Turbot VirtualBox server, and from this Turbot VirtualBox server, I'm now SSHing without a password to another remote server, Scuttle. So that's how that works. And the last thing I'll say is, if you have lots of private keys that you keep track of, or if you have keys with weird names that are not just ID RSA, then Ubuntu may not automatically, SSH on Ubuntu may not automatically find your key to use it. So you might have to tell the system to use an authentication agent similar to Pageant. You have to tell it about your private keys. So see this link for more details. So with that, I'll end the video. I hope that was useful to you.